Look at this rock. At first glance, it's just another dusty fragment scattered across Mars. But when NASA's Perseverance rover zoomed in, what appeared on the screen stunned everyone watching from mission control. Strange black dots and circular markings, patterns that looked almost alive, spread across its surface like a code left behind by time. The scientists stared, silent, realizing they might be looking at something humanity has been chasing for centuries. Proof that we are not alone. Perseverance found this peculiar rock deep inside Jezero crater, an ancient lakebed that once overflowed with water billions of years ago. If life ever existed on Mars, this would have been the perfect home for it. The rover's cameras sent back high-resolution images, revealing the mysterious markings in full detail. Within hours, geologists at NASA started calling them leopard spots and poppy seeds. Those names weren't random. On Earth, rocks with the same patterns are almost always connected to microscopic life, ancient bacterial colonies fossilized in mud, and that realization hit everyone like a wave. What if Mars once looked like Earth? The team knew what they had to do. Perseverance deployed its robotic arm and began drilling into the strange slab. This was no ordinary rock. This could be the evidence of Martian life preserved for billions of years. The core sample was carefully extracted, sealed in a titanium tube, and given a name, Sapphire Canyon. It was the moment the rover's mission truly changed from exploration to history-making discovery. When the data arrived at NASA's Jet Propulsion Laboratory, the analysis was jaw-dropping. Inside that rock were organic molecules, the chemical building blocks of life itself, embedded precisely where those circular markings appeared. Along with that, scientists detected iron, sulfur, phosphorus, and two rare minerals, vivianite and greigite. On Earth, those minerals are typically formed in wet environments filled with decaying organic matter. That combination made one explanation impossible to ignore. Mars, billions of years ago, might have been alive. To understand how big this moment is, you have to go back nearly 50 years. In 1976, the Viking landers became the first spacecraft to touch down on Mars and perform life detection experiments. When they mixed Martian soil with nutrient solutions, the results shocked the world. The soil released gas as if tiny living things were breathing. But later tests showed that chemistry, not biology, had caused the reaction. No microbes, just reactive salts. The disappointment was crushing. Then came the Spirit and Opportunity rovers in the 2000s, which proved that Mars once had flowing rivers, lakes, and maybe even oceans. Water, the essential ingredient for life, had been everywhere. The Curiosity rover later confirmed that the planet's ancient environment was habitable. Yet, even then, no direct proof of life had surfaced until Perseverance began to explore Jezero crater. Perseverance is far more advanced than any rover before it. It carries a full laboratory of instruments built to find signs of ancient biology. Among them are two key tools: Pixel, which identifies elements in rock samples, and Sherlock, which uses laser light to detect organic molecules and minerals that may have formed in the presence of life. When these instruments scanned the Sapphire Canyon sample, the results aligned perfectly with what scientists had been hoping for. Every clue, chemical, visual, and geological, pointed toward the same conclusion. This rock might be a fossil, but NASA scientists are cautious. They've seen excitement like this before, only to have it fade under closer scrutiny. So they began testing every alternative explanation they could imagine. Could the patterns have formed through non-biological processes? Maybe through heat or pressure? That theory collapsed quickly. Vivianite, one of the key minerals found, only forms at cool temperatures. Any extreme heat would have destroyed it. Could acidic water have caused it instead? No. Acid would have erased olivine minerals that were still present in the rock. What about a catalytic chemical reaction that mimics life? Possible in theory, but unlikely under the cold, stable conditions found in Jezero. The team kept checking, and every time the simplest, most consistent explanation was life. Still, as Carl Sagan once said, extraordinary claims require extraordinary evidence. And there is no claim more extraordinary than discovering alien life. That's why NASA has refused to call this proof. Instead, they call it a potential biosignature, meaning something that could be biological but needs more confirmation. To move from suspicion to certainty, they'll need to bring the rock back to Earth. That's where the Mars sample return mission comes in. Perseverance is not just a rover, it's the first stage of an interplanetary relay. Each core sample it collects is stored and sealed on the Martian surface, waiting for a future mission to retrieve it. The plan is ambitious. Send another spacecraft to Mars, land near Perseverance, pick up the samples, launch them into orbit, and then capture them with a returning orbiter to bring them home. It's a three-mission chain stretching across millions of miles, the most complicated space delivery in human history. The goal is simple but monumental: to place Martian rock into Earth's best laboratories and finally answer the question, did life ever exist beyond Earth? Inside NASA, this discovery has reignited the debate about our place in the universe. If microbial life once thrived in the muddy waters of Jezero Crater, it means life might not be rare at all. It might be everywhere. Every planet, every moon, with the right conditions could be teeming with organisms waiting to be found. For scientists, that's thrilling. For philosophers, it's humbling. Because if life emerged independently on both Earth and Mars, then life might be the rule, not the exception. But this discovery also raises deeper questions. What happens to humanity once we confirm life elsewhere? Will we see ourselves differently? Will religions, politics, and philosophies shift around this truth? Or will it simply remind us how fragile and precious life really is? Many NASA scientists say that finding life on Mars would unite us more than divide us, forcing everyone to confront how small and connected we are in the grand scale of the universe. For now, the evidence remains sealed inside a small metal tube sitting on the Martian surface, waiting for us to bring it home. It's incredible to think that the answer to one of humanity's oldest questions, are we alone?, might already be inside that container. Every rover wheel track, every data transmission, every dusty image is another step closer to knowing the truth. NASA's Mars sample return mission faces challenges: budget cuts, technical hurdles, and political debates, but its purpose is too great to abandon. If it succeeds, sometime in the 2030s, we could be holding the first pieces of another world. And when those samples are opened and examined, we may finally read the story they've been keeping for billions of years. When that happens, everything changes. The idea that life can appear wherever conditions allow will reshape how we explore the cosmos. We won't look at exoplanets the same way again. We'll start to see the universe not as an empty void, but as a living ocean filled with possibilities. Until then, that little rock on Mars waits patiently, silent, ancient, and perhaps still whispering the story of its past. Maybe it's telling us that life doesn't belong to Earth alone. Maybe it's saying that the universe itself is alive, and we've just taken our first real glimpse into that truth. So, what did NASA find on Mars? Maybe not aliens waving from the surface, not yet. But they may have found something even more profound: the memory of life itself, written in stone, preserved beneath a crimson sky.